Hi everyone. Welcome to Mobile Ajax Push with ICEfaces 2.0. You'll see as we're going to touch on all of these different topics in the title in a variety of ways. So the title doesn't entirely fit the topic as a sentence, but it describes what we're going to talk about. So first of all, I'd like to ask what people are looking for in a mobile application. Now you want to think about each of these categories. Do you want something that is tightly integrated with the device? Well, that means you need access to maybe the camera, sensors, the contact list, various things that are built into the device. Is that what you're looking for? Or do you want your application to be very fashionable? Do you want it to look just like it's a native app? Or is your emphasis on making the application portable? Meaning that, well, most of my users are desktop users, but I have some users who absolutely need to perform certain functions even from a mobile device. Well, in that case, what you want is the ability to easily write the desktop application and yet have the mobile application as a target so that it works well. And then the other general question we have is, when you're thinking of a mobile device, is it a phone or is it a tablet? Well, I think more and more we certainly see tablets, but initially people think of as mobile devices being a phone. Or why not just build a native app? Well, what's the big deal there? Of course, you have to learn a new language. In some ways, okay, so if it's an iPhone that you're targeting, you need to learn Objective-C. And then, for instance, here's the URL in Objective-C. Looks maybe a little bit familiar, same acronym, but the language is very different from Java. Okay, well, there's Android and BlackBerry, where at least we're developing in Java, but then you find out that you can't use the standard Java APIs. If you want to use a URL, you use android.net.uri, or a lot of Android packages, or org.apache packages. On BlackBerry, there's net.rim. So these are like Java Micro Edition APIs. And then what you find sometimes is that, well, perhaps you would like to use, say, an existing org.apache jar file, but it may not run on the BlackBerry, even though the BlackBerry is a JVM, because the Apache implementation is using features that are not present in a Java Micro Edition VM. So there are definitely complications with writing a native app yourself. And I think maybe the people who have undertaken it have discovered that it's sometimes difficult to find developers that have the native app skills, and it may be very expensive once you actually do find the developers that will do that. Then there's a whole other side. Now you've developed your application, now you want to get it deployed on the device. Mobile devices are highly secure environments, so the application has to be signed, and it digitally signed and approved by the App Store. That means that you can't just redeploy whenever you'd like. You have to resubmit it to the App Store, then they review it, and potentially make it available for download. Even just working with signed applications is tedious, though, because you have to make sure that all of your managed keys are correct, and then you go to deploy it to the device, and there's some mismatch in your local key store, and the deploy fails. No matter what, it's not as easy to develop as a web app. So let's look at a different way of developing applications, where we'll take the features that we want from mobile devices, but we'll develop them as web applications. Now, I've got a complicated diagram coming up, but it explains the whole thing. So I'll take us through some different aspects of the diagram. Basic idea, though, is that we want to use our existing skills and infrastructure and yet benefit from mobile features. So how do we do that? Well, this is a new system that we've put together end-to-end that makes use of all of the ICEfaces community projects, as well as this new one, which is the browser client. So as a GSF developer, you're familiar with the server-side piece here. You have a GSF component library. Well, now you can see there's some new additions to that. There's GSF components that correspond to camera, microphone, maybe GPS. Those components are rendered using the existing ICEfaces render kit, which we call the direct-to-DOM render kit, which provides automatic Ajax for you. Now, the other interesting aspect in this diagram is ICE push. So, of course, there's ICEfaces integration for ICE push. ICEpush lets you push updates to the device, such as when you have multiple users interacting, they are able to be notified of what another user is doing through the use of ICEpush. And I'll show API examples of that. But more what we've done here is we've integrated ICEpush with the notification clouds specific to each device. So for instance, if you want to display an iPhone notification, it sends the notification over the iPhone cloud and will display that in a native fashion on the device. I'll show you that in a demo. Now, as I mentioned, there are several components here supported for BlackBerry, Android, and iPhone. You can mix and match these pieces. You don't necessarily have to use ICEfaces with, say, the ICE mobile client container, or even with ICEpush. If you want to use ICEpush, of course you can use ICEpush standalone. You can use ICEpush with the client container to benefit from the cloud notification capabilities. Or you can add in ICEfaces in order to benefit from the ICEfaces components. If you wanted to leave ICEfaces out, you could use the JavaScript API that we provide as part of the container to benefit from camera and push capabilities. So all of these pieces can be mixed and matched as you see fit for your application. Now let's start with the most basic demo, which is integration with the camera. Switch to the video here of the devices. I'll go into the camera demo. So this particular camera demo is an ICEfaces page. You can see that we have camera button, which is from the ICE camera component. It displays the camera. We use the front side camera. Here I am with the webcam. Now we can take the picture. Let's use that. Now what the camera component has done is that it has generated a base64 encoded thumbnail, passed that back into JavaScript. So that if we wanted to keep that image, we could, which we will. Or if we wanted to take a new image, we could press the camera button again and take a new image. If you're familiar with GSF, it's as if the camera is just the value, or the value is an image. Now we press a regular submit button to upload. What it's done is it's uploaded the value of that camera component, like a file upload, and added it to our web page using an hreflang image. We'll go back to the slides and explain how that worked by looking at the code. So what do we need in that camera page? Well, we need a form. The encoding type of the form, strictly speaking, you don't have to set the encoding type if you're using the ICEfaces container. But if you want it to be portable between the ICEfaces container and, say, a desktop browser, you'll want to set the encoding type to be multipart form data. Because what the camera component does is it detects whether it's using this ICEfaces container that provides access to native capabilities or whether it's using a regular web browser. If it's using a regular web browser, the camera component renders out an input file. So a desktop user could just browse to their file system and upload an image if they wanted to. So that's for the desktop user that you need the multipart form data. Then to insert the camera button in the page, you just have a camera component. You can give it an ID, and you give it a value where the value is the image. And the thumbnail component needs to know which camera component it's displaying the thumbnail for. So we do that with for camera. Then there's a regular upload command button. We just bind that to an action, and we display the image as part of the page. In our bean, here's something we're doing a little bit different with the camera upload as a file upload. One of the problems when you implement a file upload in GSF is you may require custom types, and you don't necessarily want to have custom types in your bean. So what we've done here is passed in the image as a map, because the image file isn't just going to be an image. It's going to be an image with some metadata. So So what the map allows you to do is use a standard Java type. So this is a POJO bean, where you can just retrieve the file as a standard Java file out of the map. Another possible strategy would have been to just have the value of the camera being a java.io.file. But that wouldn't have allowed you to pass back metadata, such as the name of the file as specified by the device, or in the case of images, there can be some other interesting metadata, such as the size and the exposure and various things that might be conveniently accessed at this point. So what do? We get the upload, it's set in as a value, and then from that value, we can move the file where we want it, generate a URL, and have a getter for the URL so that that current image can be displayed in the web page. We've implemented a variety of components according to this strategy. Camera, like video is not quite done, but we'll have video upload soon. There's a microphone component where you can record audio. Now, the microphone component is a little bit different because it doesn't change the display on the device. You just press start recording, and then it records in the background while you're still looking at the web page, and you can stop recording. So you can build your own walkie-talkie with something like that. Of course, there's the thumbnail, which you've already seen, and a geolocation component. Now, geolocation is a little bit different in that it doesn't actually require native access to the device. There are HTML JavaScript APIs that provide geolocation, but we consider it still a mobility feature because the most likely place you're going to find geolocation of interest is for a mobile device. Now, you're probably wondering, what is there involved in writing a component that has these features? There's a little bit that you need to do. So, as usual for a GSF component, you need to implement the component and a renderer. In your renderer, you'll want to detect whether it's being rendered to an enhanced container that provides JavaScript APIs for device access or not. If it's not an enhanced container, well, you just say in the camera example of the camera component, you just render out an input file. If it is an enhanced container, then this renderer renders out an on-click that calls the simple ICECamera JavaScript, which hooks into the container and displays the image picker or the camera interface. Well, you need that ICECamera to exist. So if you're writing this new custom native API, you would need to augment the JavaScript file that's stored on the device. And we do store it on the device because there's no sense in downloading JavaScript from the server that's specific to the device and requires native code to be present there to do that. Although it's not much JavaScript. So the performance gain is small, but the layering is correct in doing it that way. Then you'll need to implement native code. Now, the native code is where you'll see the most divergence between the different devices. Android and BlackBerry, it will be Java code, but it will be very different Java code because you're calling device-specific APIs. So you'll need native code to display the camera user interface, save the image, and eventually upload it. But how does this upload actually take place? Because it's bulk data. It could be very bulk. You could have gigabytes of data potentially. For a camera image, probably not. You probably have a few megabytes. But you still don't necessarily want to transfer that image data from the native realm back into JavaScript. You would wonder, well, how are you going to do that? For the thumbnail, we use base64 encoding. In other words, we take the image and we encode it into a text string, and then the text string can be displayed by the browser. But for megabytes of data, you probably don't want to create several megabyte string, pass it back into JavaScript. Potentially, you could even crash the browser with data that's too large. Really, what you want to do is you want to keep that bulk data, such as your video recording, on the file system, and then when the upload actually occurs, it asks the native layer to upload all of those blocks of data, plus any other form values. So that's what the ICEfaces mobile container provides, is it provides the camera APIs, which call into the native camera functions, as well as an upload function that, with any identified by ID images, will upload those images directly from the file system, as well as the serialized form from JSF. And We'll create a post. This post is being handled by the native code, posted like a JSF Ajax request. Now let's look at Cloud Push. We'll go to a demo here. So for this demo, we're going to show push occurring from the desktop to the browser. Go back to the index page. Load up the Cloud Push demo. So in the normal case of ICEfaces Ajax push, we can enter in a value, click send. Oops. Let's use a, so you can see the device on the left. And like I said, I want to send this way. So I say send, you can see that it was pushed to the device. It says hello. Now, the user is either maybe going to leave the container application, or they'll lose network connectivity, and network connectivity will come back. So that ICE push is effectively paused at this point, and they're out of the application. Well, now, your ICE push, or ICEfaces Ajax push application has no way to talk to that device, apparently, because the ICEfaces portion is no longer being displayed. But in fact, we can, by sending, you see that when I press send, now we see the notification in a different form. This is native Apple push notification. So if I view, then I'm brought back into the ICEfaces application. Does that make sense? Okay, so let's go back to the slides, and we'll discuss what happened. So that's Cloud Push. Just to remind you about how Ajax Push works in general. Here's Neil, here's Ted. We're both viewing this slideshow. And Neil advances the slide, say. That message is sent to the server. Well, the server processes it, and it wants to push to desktop users, which are using ICEfaces and ICEpush directly, and to potentially offline mobile users through the Apple cloud in order to send that notification. There's probably several reasons why you would want to use the Apple notification service in addition to ICEpush. Even if you have the ICEfaces application displayed, you might want to use the Apple push notification service, because the Apple notification service does not require a TCP connection to be open all the time. It's directly aware of the device, and in that sense, it will be more power efficient. But it's especially important when the user is no longer in the ICEfaces application and you want to push an update to them. Well, what's involved in the application code? Is it difficult to write something that does this? Well, if you're familiar with the push renderer, it's not. The push renderer, we put our users into groups. So we can add a current session into a group, such as the chat group. This allows you to refer to any of the many windows that the user has open. You just work with them by sessions. When we want to update one of those views that the user has open in that session, maybe we set a value in a backing bean, we just request that that group be rendered. What that will do is it will send a notification to all of the browsers that are connected. Then they will request updates via Ajax. A render will occur on the server for each of those GSF users, and their pages will be updated. But it's different in the case where the ICEfaces application is not being displayed at that moment, because it's not going to receive the ICE push notification through JavaScript. The only way it can receive it is through the cloud. But there's another factor here too, in that you don't necessarily want to send all of your notifications over the cloud. If the user is actually viewing the ICEfaces application, you may want to update the page in sort of minor ways. Only when something major happens, like say you're in an auction application and your bid was exceeded, do you actually want to notify the user. So in that case, instead of just calling render, you call render and you pass in another argument, which is a push notification. Passing in this push notification is a signal to ICEpush that it should use the cloud notification system if it's necessary for the device. So what this means is that in your application, you do not have to keep track of whether the user is currently online or offline. You only need to say that, well, if the user was offline, this is how I would want them to be notified. I'd like them to be notified with a message, and there it is. Perhaps none of your users are offline at that moment. Or maybe they all are, in which case all of them will be notified through the cloud push mechanism. Now there are other bits of metadata that you can pass through this push notification. Maybe you want to change the LED state or play a sound. You can use that through different constructors of the push notification API. Now there's a few more features that are of interest in the mobile push implementation. Of course, the cloud push, which I've been telling you about. Now in general, everything I'm showing you is open source, except for, in the case of the Apple push notification and the C2DM and the BlackBerry push, those require some certificates as well as special server-side APIs. Those particular notification systems are not open source. Those are part of the Enterprise Edition. What we do provide as open source is an email-based notification, so that you can test out the notification capabilities in your application. Then the other feature that is in the Enterprise Edition is an adaptive heartbeating capability for ICEpush. What we observed is that in different mobile environments, the networking characteristics were different, and the typical heartbeat values that you might choose for an ICEfaces desktop application were not suitable. So we made it so that the heartbeat value will dynamically adapt to the network conditions that are there, and that gives your users a good indication of whether they actually have a valid push connection at that moment. So as I mentioned, there's some additional features to the Cloud Push API. You could pass in text, maybe you want to change a badge on the icon, or sounds, change the LED state. Each of these abstract things is displayed on a given device in a particular device-specific way. For instance, the device may not even have an LED. So if you choose that option, it will be shown to the BlackBerry users, but not the iPhone users. So this is to wrap up these mobile-specific device integration features. In iOS, we support iPhone, iPod, and iPad. In BlackBerry, you do need BlackBerry OS 6. It's the modern operating system on the BlackBerry. Playbook, we are looking at the Playbook, but we haven't yet developed an implementation for it because it is actually a completely different device. It's not developed using those net.rim APIs at all. It's developed through Adobe Air. So it's more of an action script or a Flash plugin hooked into the browser. So it's quite different. Variety of Android versions, 2.2 to 3.0. Now, if you don't need these device-specific capabilities, such as the Cloud Push or access to the camera, you can just run your ICEfaces application in the regular mobile browser that's on the device. That will still allow you to benefit from Ajax Push. You just won't have the capability to have Ajax Push over the device-specific cloud. So what are some of the reasons why you might use these native integration features? Well, native integration, such as access to the camera, is one important reason, or access to their contact list. But in addition, it does give you an app icon on the device, so as an icon that the user can press and immediately go into your application with no URL bar and no back button. You may not want the user messing around with those aspects in your application, so you can give a very simple and easy to use application. And then, of course, you can customize the entry to the application, or the icon and the splash screen. I think more we'll also see applications that have specific security requirements that go beyond what you'd have with a normal web login. If you need to provide some certificates and encryption built into the application itself, you can do that at the networking layer, and then after that, it's still just a regular web application. So that gives you some additional security capabilities. Then network policy, well, network policy, part of that could be the security, but it could also be a policy in terms of if the device is not able to connect, how soon should it retry? You can build that directly directly into your application. Rather than having the user pounding on the reload button when you don't want them to be doing that, you can have an automated policy built into the application that allows the application to connect and provide the features that it needs to in a faulty network environment without burdening the user with that poor user interface. And then finally, I think another interesting area will be integrating with devices that are connected to the mobile device. Maybe sensors or a card reader, or could be, I guess it could be a running shoe. In the case of the Nike integration, you would have access to that from a web app. But you don't always have to have native API integration in order to have an application that looks like a native application. So in that case, let's look at the PhotoShare demo. Where here, the device will customize its appearance, or the application will customize its appearance based on the device. So we'll go to PhotoShare. Now, as it turns out, our BlackBerry theme essentially looks like the Android theme. But what you can see is that the appearance of the iPhone application is quite different. So let's use the Android to take a picture. I can see it has a different appearance. We'll unstick it from its table here. We have the thumbnail. When we send the message, pushed to the other users. I shouldn't have given up on the BlackBerry so quickly. There it goes. I was about to. So what you can see here are definitely customized theming. So that's done with the CSS component. On the server side, we have a variety of CSS files that are customized to each of the devices. And it detects the device type coming in from, in this case, it's not the user agent, but the user agent combined with a value set in by the ICEfaces container application. Now we can serve CSS that's specific to the device. Then in addition, we have scrolling features, say on the Android, as well as icons and buttons that are tailored to the device. So these are giving you, in some cases, the theme of the device that it's running on, or simply mobile features in your application that are typical mobile user interface features. Those are provided by these components. The idea is to give a native look and feel to your application. So one very nice thing about developing for mobile devices is that we can use some modern web features on these. We're not trying to target Internet Explorer 6 with any of this capability. So we actually have essentially the same browser on all of those devices that I've been demoing. It's all based on WebKit, which is similar to the Safari browser. And it's a completely modern browser. So even on these smallest devices are in some ways the most advanced browsers that we have access to. This lets us finally do some things that are using new HTML5 APIs for mobile components. So that's very nice in terms of developing code for them. As I mentioned, there's device-specific styling, touch controls such as scrolling, and lists, as you saw on that main page. In order to benefit from From this, you don't need that enhanced container. You can run this in the regular browsers that are available on those devices. So if that's what you're after, is giving a native look and feel to your application, ultimately, all it is some HTML, CSS, and some JavaScript in order to give you those capabilities. But of course, what's nice is having those native look and feel capabilities provided to you through JSF ICEfaces components, which we have. So you can see that the iPhone theme is different from the Android theme. And then there are various buttons that are of an appearance that the mobile user expects. Now let's switch gears a little bit and go into some theory.
Are you supporting all of the current ICEfaces components with the different look and feels?
No, we'll likely create new components that are well suited. Now, some ICEfaces components, if, say, a button, a button should legitimately be translated just into a mobile button, and it should appear in that way. But something like drag and drop, we are not translating because drag and drop is not always, because the dragging is the scrolling interaction on the device. So it'll be on a case-by-case basis about which components. Some will be new components, and some will be augmenting existing components. In a lot of cases, it's just a matter of providing a root style sheet that's appropriate for, say, all the input type button. So in that way, they'll automatically benefit from that styling. Now let's switch gears and go into a little bit of theory about what we're dealing with in the mobile environment. These mobile devices are actually fairly fast, but that's still not an excuse for using a lot of CPU, because even though the device is fairly fast, it's running on battery power. You want to use that device efficiently, because otherwise, at the end of the day, the user is not able to do anything else because their battery is dead. And the other major constraint is the connectivity. Mobile device isn't very fun if it's connected by a wire to the wall. So we have to expect wireless networks where connectivity can appear and disappear. That's one of the reasons for using the cloud notification systems, is because when the device does come back online, the cloud is able to notify it. Then, as an application designer and a component developer, we have to realize that the screen is smaller, and there are different constraints there. One particular constraint, as you saw when I was entering that IP address in at the beginning, is that entering text is not as pleasant on a mobile device as desktop keyboard, at least not for me. So how do we address these? How do we use less CPU? Well, you can simplify the markup that you send down, and you want to make the JavaScript very efficient, because you will pay a price when the JavaScript is interpreted as well as when it's executed. Now, one important way, and this is especially tailored well to GSF to conserve battery power, is that we can write a predominantly server-side application. Server, we have plenty of CPU and plenty of power. So if we can delegate functionality to the server, then the device can do less and it can run longer on its battery. Then to conserve the network, at every stage it's important to reduce the size of what we send down to the device. So that means reduce the size of the JavaScript, use Ajax so that we're just sending the page updates rather than full page refresh. Web 1.0 is not as good on a mobile device as an Ajax application. When using Ajax push, user can be interacting, an update can be pushed to them, can simplify the way that they use the application and make them better able to get more done, even though the network is not as solid as it might be for a desktop application. And then finally, we'll use the cloud in order to send push updates to the device. To handle the differences in UI on the device with a smaller screen and maybe the absence of a keyboard, you want to simplify the application design. You want to show the user just what is necessary. So as they work their way through the application, update the page to show them what is relevant. And then, as I mentioned before, we'll have custom ICEfaces components that are specially designed for mobile devices. So that takes us to our third topic, essentially third topic, which is how to make an application application that's portable between the desktop and the mobile. So this is for the use case where you say, well, the majority of my users are desktop users, but there are also mobile users, and I would like them to benefit from the same functionality. Let's bring up WebMC. And we'll bring it up on the mobile device. Brief intermission here while I type in an address for the laptop. So I'll enter in my name and join the presentation. Now this one is best viewed in landscape mode. Slides are updating automatically. For this user, I'll join the same presentation on the desktop. Now you can see that the mobile user and the desktop user are looking at the same presentation. Let me show you the chat feature. And you can see that the chat message was pushed to the mobile user. So the interesting thing here is, how do we develop an application like this? We want to reuse code. Well, our Java beans, of course, can be completely reused. Most of your pages will actually work on a mobile Safari browser. They might not look very good, but they'll probably work. But you want it to be better. So what should we avoid? There's no sense sending an image that's larger than what the device can display. The display is smaller, so you don't want to clutter it up. You can't do drag and drop. Scrolling is a nuisance for a mobile user. And you want to use Ajax in order to make an effective application. So how do you avoid large images? Well, using Java 2D code, you can transform them, reduce the size. So you can create a set of images that are encoded for the mobile users and a set that are encoded for the desktop users. As far as the basic icons, the theming features that we have, a lot of those are shared across the application, mobile or not. We only really did this technique for the main slides that are displayed in that slideshow application, because those are large images and they're dynamically generated anyway because of the user uploading the slides. In order to display it to the mobile users, we simply adjust the URL, customize that for them. So how do we customize that user interface for the mobile and desktop users? Well, in the case of the desktop, we have a variety of header and footer elements, and you can see that the buttons have text labels on them, such as the word send. There's some tabs, let them switch between the help screens, which are fairly large. For the mobile user, we don't want all of that. Now, what looks like the same kind of footer is not actually the footer of the application. It's the footer on the slide that's being displayed. Now you can see that the chat interface has been simplified considerably. It doesn't have the decorative tab on the top. And the send button is just a button. It doesn't have the word send. So you can make a lot of little tweaks like that that will really slim down your application and make it look good on the mobile device. So how do you do that? Well, with GSF, it's really quite simple. One technique is you just detect whether it's a mobile user or not based on the user agent, and then turn on and off separate panel groups. I think what we will want to do with ICEfaces is provide a set of components that let you turn decorative pieces on and off easily, rather than having to have the rendered equals and device detection. But look, it's very easy to implement within application code as well, as we've done for WebMC at this point. To keep the application the right size on the display, and so the user doesn't scroll around within it, you can give meta hints to tell the mobile device what the initial scale should be and whether scrolling is allowed. And you can pass those as saying that the viewport should be of the full device width. You don't need to hard code pixel values into this. You can say that, well, the viewport should fill the device screen, and that's what you want. So those are important tags to use. And then in terms of implementing the application, it's really just an ICEfaces Ajax application. We have some markup that declares our namespaces. We have an output region. There's a text saying that we have a presentation and the URL for the current slide. The current slide is updated in the backing bean. Chat is a matter of printing out the chat that's been received, collecting chat input, and having an action for a command button. The bean, the most interesting part of the bean is the getter for the slide URL. This is updated by the moderator or by a timer task in the case of these automated presentations. When you change the URL, issue a push request, all of the slideshow viewers will be updated. And you can view the chat log and collect chat input. The Ajax push part is simple, as I mentioned. Add the current session using the push renderer. Add the current session to the particular presentation, because each presentation that's being given on the server should be in a separate group. And then you just render that presentation. All of the users that are viewing that presentation will be notified, and they'll all update to the current slide that's been advanced in that presentation. So very, very simple to add that push feature. Now, I'd like to show another simple demo in case you're not convinced that you want native look and feel components or ICEfaces components at all. Maybe you'd like to do some of this mobility stuff just using JSP. Let's switch to another demo. So in this demo, we'll create a new blog that's empty. On the device, we're going to go in the admin interface for the blog, which lets us like I said, the admin interface. The GSP application lets us add in say a title, which will be, I don't know, mobile Ajax push. And now let's take a picture. There's a front-facing camera. There's another picture of the camera with me. Oh, it goes into a thumbnail. Now, you've seen something very similar to this, but that was using ICEfaces components. This is just using GSP, where the GSP is writing out ice.camera and the thumbnail. So upload it. That uses IcePush with the GSP integration of IcePush to push an image to the blog. For instance, you could use this, you're in one of the keynote sessions, you could just capture everything that's happening on the screen, type in a few comments, and it would gradually add into the blog post with the various images that are uploaded. And that's just using plain GSP. So let's quickly look at the GSPs that we need in order to implement it. It's quite simple. We add an on-click handler. We have a thumbnail that has an ID that matches the camera component. We have an on-click on the upload button that detects if it's in a mobile environment, in which case it calls ice.upload. Otherwise, it just submits the form. So this is portable between the regular desktop browser or the enhanced container on the mobile device that has native capabilities. And then, as part of the admin GSP, we look through the parts. This is using Servlet 3.0. We look through the multi-part upload, find the file that we want, and then add in an image into that blog post, an image tag with the file name. So Servlet 3.0 makes it really easy to do this file upload and automatic output. And that's all there is to it. So I'd like to thank everyone for coming, and how about stop by the booth and you can have a t-shirt. For now, let's wrap it up. You have a question? Sure.
Would it be possible to take like for example, the iPhone application, the mobile engine, and make that available in the App Store, so that it makes it very, very easy then, so I can just download the one app and then maybe have a list of all the ICEfaces, JSF applications, and I can just touch and then I can connect it to it right there, kind of like a favorites menu.
Right.
Right there. Because one of the pain points that I've seen, at least for iPhones, if you want to make an application, that's not going to be in the App Store. It's quite painful to install it on all the devices. Apple's not necessarily. They're going to make it easy, And so if there was just one app that I could download from the App Store and then connect to multiple mobile ICEfaces applications with it, that would save a pain.
Yeah, that's a good question. Is how do you deploy this application, in particular for the iPhone? So what we plan to do is submit a generic container that does say contain the ICEfaces demos as an iPhone application. You can download that, and then you could use some of the ICEfaces demos with it. Now, of course, you're going to want to customize that application, or some people will, for their own specific enterprise application, in which case you'll need to take the code for that application and compile your own version and submit it to the App Store yourself, or we could submit it to the App Store on your behalf and assist you with that process. Then the other option that you mentioned is what's called ad hoc distribution, which is where you're allowed to have a list of 100 devices, and you can say, okay, I'm going to add each of these devices to my provisioning profile, and then you can deploy the application to each of those devices. So but that requires you to maintain that list of devices, which isn't always convenient. Yeah, and so that I think that is the interesting thing is how do you deploy these applications? No. Okay, any other questions? No?
Yeah.
Thank you.
Do you know when any of this will be available?
Yeah, we're expecting to have an alpha this summer. So that will be an open source variant of that container, and you can build your own application and submit it to the App Store. Or make use of, say, just mobile look and feel in an ICEfaces application. All right, thanks everybody.